Every time you type something in your browser, a whole new world of communication begins behind the scene. But how does your request actually travel from your device to the website? Let's find out through the IP model. Today, we will explore how data travels like a digital letter from sender to receiver through the layers of the IP model. Think of the internet as a vast postal system, except our letters are packets of data flying through wires and routers instead of streets and mailboxes. Just like a postman picks up your letter, adds the correct address, and ensures it's delivered safely. The IP model guides your data through a similar step by step journey. Except this postman doesn't need a scooter. He rides on fiber optics. The IP model has 5 layers and each has a special role, kind of like a well organized delivery team. The application layer decides what to send. The transport layer breaks it into pieces. The network layer finds the address. The data link layer manages the local delivery. And the physical layer carries it across wires or Wi Fi. Together, these layers wrap your data like an onion, layer by layer, adding all the information needed for the journey. Now that we have packed up data neatly, let's see how it actually travels layer by layer through encapsulation and decapsulation.
Let's explore how encapsulation works in computer networks, the process that wraps data with necessary information before it travels to the internet. Every message you send passes through multiple layers of Internet Protocol model: application, transport, network, data link, and physical. Each layer adds its own header, preparing the data for the next stage, just like packing a parcel step by step. At the sender side's encapsulation begins. The application layer creates the data. The transport layer adds a TCP header forming a segment. The network layer adds the IP header to make a packet. The data link layer adds frame header and trailers. Now it's a complete frame. Finally, the physical layer converts everything into signals that move across the network. This fully encapsulated frame now travels through routers and switches until it reaches the receiver. Each layer's information ensures that the data knows exactly where it's going and how to get there. When the frame arrives, the process reverses. That's decapsulation. The data link layer removes the frame header. The network layer removes the IP header. And the transport layer removes the TCP header. Finally, the application layer receives the clean original message ready to display, just like opening a digital envelope.
Let's take a real life example. Imagine two friends chatting on WhatsApp. One types a simple message, "Hey, what's up?" and presses send. At that exact moment, the message doesn't travel as one big piece. Instead, it's divided into many tiny parts called packets. Let's see how these packets work. Each packet carries its own information: a source port and destination port from the transport layer, and IP addresses that tell the network where it's coming from and where it's going. Now these packets begin their journey through the internet. Routers act like post offices, reading the IP addresses and forwarding every packet along the fastest path available. But what if one packet gets lost on the way or delayed because of heavy traffic? The transport layer using TCP ensures reliable delivery even when packets are lost. When all packets reach your friend's phone, they join together to form the original message. Every time we send a simple text or meme, this quick process happens in seconds. That's the magic of the TCP/IP model.
So, why does the IP model work? The Internet Protocol model is genius. It's modular, flexible, and reliable. Each layer has one job and it does it perfectly. Upgrade the vans, not the postman. So if we upgrade the 4G to 5G, only the physical layer changes, like replacing an old delivery van with the faster ones. Now comes the network layer. It acts like a postmaster. It always finds the best route. If one road is blocked, packets are instantly rerouted to the other route. Now comes the transport layer. It ensures reliability. It checks if the packets are missing. It traces the missing packets and then sends them successfully. From text to cat videos, every device speaks the same IP language. That's what keeps the internet running everywhere, every second. So the next time you hit send, imagine billions of digital postmen delivering your data. No delays, no postal dues, and no chai breaks.
And that's how Digital Postman ensures that every bit of data reaches safely from sender to receiver.
Created using Powtoon.